You're on. This is Friday, September 13th, year of our Lord 2019, pre-algebra class. And before we get started on today's lesson, we're going to go back to page 27 and see if you were able to figure out number 6 on your own from page 27.
I think I got it.
As we get started, a little outside, this isn't totally outside of math, but in 5th grade Bible, we wrote these 2 words down. 7th and 8th graders should know what these words mean. Anybody want to take a stab at it? What does the word omniscient mean? Omniscient. Yes.
All-knowing.
All-knowing. Who's all-knowing?
God.
God's all-knowing. And what does the word omnipotent mean? Omnipotent. Omnipotent. Noel.
He is everywhere.
That would be omnipresent. There is a word for that. Omnipresent. Yes.
He's all powerful?
He's all powerful. Potent. Powerful. Who's all powerful? God. Are you?
No.
You like to think so sometimes. You might not admit you like to think so, but you like to think so because how often do you just try to go on your own, not even include God, not even talk to God? So you actually, in a way, are so prideful that you think you're all knowing and you're all powerful because what do you need God for? Even though you would never say that. I'm talking to myself too. Live like that too. And then we've got, this has more to do with math. What is that? Don't be triskaidekaphobic.
What?
Oh.
You should remember this because I think when one of your classes was in 5th grade, this was on the board when you were in 5th grade. Noah's got it.
Is it like the fear of division?
No, that's divisiophobia. I'm not calling you again. You probably know the answer. I want to give someone else a chance. Yes.
It's the fear of the number 14.
Of what?
14?
Why 14?
Because I don't want to say it.
Did you get Noel's joke?
No.
She said it's the fear of the number 14 because she's so afraid of the number,
Oh.
what's today?
13.
Now, the good thing would be is if you're young Christian people and you're out there, so Friday the 13th. Well, there are people in the world, believe it or not, that are really crazy. And they won't even get out of bed on Friday the 13th because they're so superstitious that they think something really bad's going to happen to them. Believe it or not, people are like that. That's not Christians. Right. Christians don't think that way. We're not superstitious. So we are not triskaidekaphobic. That was a really good joke, Noel. Fear of the number, and she said 14 because she was so afraid to say number 13. That was a really good joke. She knew the answer.
Well, it's a funny book, so like they had like columns, like funny ones. There was one for 13, and then the next chapter was supposed to be 13. They crossed it out.
Right, listen. Whoa, when your teacher talks, your mouths are closed. Did you know that there's buildings
No.
that go from floor 12 to 14? No, seriously. You didn't know that?
I did.
Yeah.
I did.
It's such an irrational thing that there's buildings that you go in the elevator and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14.
Seriously?
Yes. Of course, we don't think that way. All right, number 6, page 27. Before I get your answer, if you were stressing over this, let's walk through and think of what could have been a problem-solving strategy we could have used. It told us that we're going to sell a total of 14 tickets, right? Think with me here. It said that we're going to get a total of $142. 14 tickets, $142. It told us that one of the items was $9 and the other item was $11. Think with me here. If we're going to sell 14 items and it's going to come to a total of $142 and one of the items is $9 and the other item's $11, what would be a logical starting point for me to think of how many of each I would sell? I have to sell, I'm selling a total of 14. Yeah.
Maybe 10, like 4.
Okay.
That's like a
That might seem logical. If I sold 10 of one and 4 of the other. So if I sold 10 shirts, that's 110, and 4 hats, at $9, Is that what it would be?
No, but it would be.
No, but that's what the price would be, right? And if I added those up, 146, that was a good starting point. So maybe I need less hats or less shirts and more hats, right? Do you understand? This is all it was. At the top of this lesson, it says trial and error or guess and check, and you revise it. But the point was, you need a good starting point. Would it have been wise to start with, I'm going to sell 13 shirts and one hat?
No.
Rachel.
You could do 6 and 8.
Okay, 6 and 8. Did everybody get 8 and 6?
Nope.
It ends, no?
No.
Ends up being 8 shirts for $88, 6 hats for $54, and you get $142. All right, let's move on. What did we start talking about yesterday? We talked about something you're familiar with, perimeter and area. And the 2 formulas you've learned so far in your life are how to find the perimeter of a rectangle, and then you realized at some point, some of you later than others in 5th grade, that there was another special kind of rectangle called a square, because some of you, when you first heard that a square was a rectangle, you're like, a square is a rectangle, right? It's a special rectangle because it's got all sides the same. So you take the perimeter for a rectangle and you simplify it when you talk about a square, because the length and the width of a square is the same. So let's reacquaint ourselves with the perimeter of a rectangle. Perimeter is 2 lengths plus 2 widths. If this was 8 and this was 7, and I knew it was a rectangle, Lauren, would I have to measure all 4 sides of this, or could I just measure 2 sides?
2 sides.
I would just have to measure 2 sides, Lorelai, if I knew that this was a rectangle. Because once I know this length, I know that length. So if I'm going around the rectangle, 2 of those lengths, plus, once I know this width, I know that width. So it's plus 2 of those widths. So to find the perimeter of a rectangle, you take 2 lengths and add it to 2 widths. I also showed you back then that I like a different way of saying this. To me, it's easier for me to have in my head. This is also the same as, for some reason, this fits my mind better. Just take the length plus the width and multiply it by 2. Anybody else like that?
Yeah.
Instead of going 2 lengths plus 2 widths, just add the length and the widths together, 15, and multiply it by 2. Because if I start here, I go 8, 7, and I know that there's going to be another 8, 7, so I just add those 2 up and multiply by 2. So either one of these you can use for perimeter. What about area? How's area different than perimeter?
It's just length times width.
Yeah, the formula for it is so much easier. You just go length times width. So if I need, but the big change when it comes to area is you're not measuring it linear measures. You're not seeing how many feet something is. You're not seeing how many meters something is. You're talking about, thanks, Jonathan, square feet or square meters, because your units then are, and again, excuse my artwork, 1, 2, 8 long, 7 wide. How many squares are in there if I was a good artist? How many perfect little squares are in there, Kira?
56.
56, because it's 8 times 7. It's that simple. I don't have to count them all. Everybody got it? Now, a square is a special kind of rectangle, so you simplify things. If I know that that side's 6, I know that all sides are 6. So if it's a square, the perimeter is just take that side and multiply it by 4. If it's a square and I need to know the area, I just take the side, 6 times 6, and there's how we write it, because we're sophisticated math students now. Instead of, look, isn't this the same thing? A square is a rectangle. Isn't this, Preston, isn't this idea, length times width, the same as this idea, side times side? What's the length of the square? 6. What's the width of the square? 6. So the formula changes to, it's still the same thing, length times width, except now we call it the side times the side, or since we're big kids now, we say it's side squared, because you're multiplying it by itself, because they're both the same. Does anybody need more review of perimeter and area? Because if you don't need more review of perimeter and area, we can get to work right now, because there's more homework today since you got off scot-free yesterday. All right, ready? You got a question? Go ahead.
Well, it's not really a question. Can I have a cough drop?
I might have one. Why? Somebody have one? Look at that. Woo!
Thank you.
Any questions on perimeter and area? Oh, in this lesson, wait, one more thing. We already talked about this. There's also this in this lesson. What's that the formula for? What's it the formula for? Distance equals rate times. What's it the formula for? What are you trying to find there? You're not trying to find perimeter or area. You're trying to find speed. Okay? You're trying to find the speed of something. Now watch this. Brett, remember yesterday I had that word algebraic axiom on the board? And we said there's 4 of them. You can add the same thing to both sides of an equation, and it'll still be equal. You can subtract the same thing from both sides of an equation, and still be equal. You can multiply the same thing on both sides of the equation, and it'll still be equal. And you can divide both sides by the same thing, and still be equal. So watch what I do with this formula, Sid. Watch. This formula here is the same thing. If I want to find rate, what will I do? If I wanted to find rate, how do I get rid of the t? It's rate times t, so how do I get rid of the t on that side? If I want to get r by itself, how do you get rid of something? You do the opposite of what they did. They took r and they multiplied it by t, so I'm going to do the opposite, undo it, and divide by t. Think about it. If I went like this, if I divided this side by t, what's t over t? What's anything over itself? 1. So I would have just r on that side. Look at everybody looking at it. Got it? So if I divide this side by something, what did I just say? I got to divide this side by that. So this is true also. Everybody take that in. If you don't understand, raise your hand. D equals r times t. And if I want to know what r was, I would divide both sides by t. Because I want to get r by itself. See that? Could somebody tell me what else would be true? What if I want to know what t was? Based on what I just did to find out what r was, how would I know what t is? Use the same logic. If I want to know t, how do I find out? What did I just do to find out what r was? If I want to know t, I got to isolate it by itself. 1 person? 2 people? 3 people? Only 3? Who give me 4? I got 3 people to know how to find t. Who give me 4? I got 4. Who give me 5? Oh, we got down to 3. Back down to 3. What do you think, Bella?
D equals R over D over R.
T equals D over R. Watch. She's correct. T equals D over R. If I want to find out what T is, what do I have to divide both sides by? How do I get rid of this R? Yeah. This is T times R. So how do I get rid of it? Should I do my carry under it? How do I undo it? How do I undo the R? T times R. How do you undo that? How do you undo multiplication? You do the opposite. So if I divide this side by R, I just got T. if I divide one side of an equation by something, I must divide the other side by that. D divided by R. I don't have such confident looks. All right.
Wouldn't it be R divided by R too?
Well, look, if I was going to break it down and go real slow, watch. D equals RT. If I wanted to know what R was from that formula, I would divide this by T, this side, and this side by T. T over T is 1. That leaves me with just R over here, and I got D over T over here. R equals D over T. If I wanted to find out what T was, I got D equals RT. I'm going to divide both sides by R. Those cancel each other out. I got T equals D divided by R, because R over R is 1. Does it make any more sense?
Yeah.
Listen, it goes back. The algebraic axiom goes like this. You can add, subtract, multiply, or divide both sides of an equation by the same thing, and it'll still be equal. And how do you undo multiplication? You divide. How do you undo addition? You subtract. How do you undo subtraction? You add. How do you undo division? You multiply. So whatever they did, if I took this formula, they had R times T. So I'm going to say, okay, if I want to know what R is, I'm going to R times T divided by T. That gets rid of the T. As long as I do it to both sides, D divided by T. All right, let's get to work. And when you get to that problem, I'm going to be here to help you through it anyway. Ready? Numbers, starting on page 36. Numbers 7 through 31. You do still have 19 minutes, so it seems like a lot. But if you get going, I'm hoping you'll get most of the way done. 7 through 31, starting on page 36.
Whoa.
How many problems?
24.
How many problems?
24.
How many problems? 25.
Wait.
Haven't we been through this before? 7 through 31 seems like 24 problems because 31 minus 7 is 24. However, you're doing number 7 also. When you say you're going to do up to number 6, it's only 6 problems because you're not including 0, right? Your starting point would be 0. 1, 2, 3, 4, 5, 6. But when you do 7 through 31, your starting point is 7. You include it. So 7 through 31 seems like 24 problems. It's 25. Does that make sense? Because when you count something from 0, you don't count 0. But when you count from 7, you're actually doing 7. Yes?
Do you care which the parameter formula?
No.
Do we have to write out?
Do you have to show you're working up? Let's see. Page 36. You have to write the formula every time. Trying to see if there's a number 16. You don't want to use mental math. So yes, write the formula so that you are thoroughly. The more you write it, the more you know it. Remember what education is? You see it, you hear it, you say it, you write it. And if you don't get it, you know what you do? You see it again, you hear it again, you write it again, you say it again. And if you still don't get it, you know what you do? You say it again, you write it again, you hear it again, see it again. And if you still don't get it, Lauren, you know what you do?
Go to your teacher.
You see it again, you hear it again, you write it again, you say it again. Until you get it. Just like, hey, I'm not good at free throw shooting, so what am I going to do? Moan about it, or am I going to go out and do it again, do it again, and do it again, and do it again? Until I get better at it. What's more important, math or free throws? Don't answer that.
Free throws.
Math. Neither. I'm basketball.
Or I'm not good at, all I know about the game is bump, set, spike. I'm not good at spiking. Well, maybe you need to be told that. I'm not good at setting. I'm not good at setting, so I've just decided I'm not going to practice it because I'm no good at it. No. What do? Practice it.
Yeah, but we only need 5 setters.
Yeah, Bella's our setter.
But next year, you
Bella will
practice.
still be our setter.
Not necessarily.
Her in high school.
Not necessarily. Jordan, things can change.
Yeah, but they You Lydia will do it. Yeah. It'll be Gigi, and then she'll work replace Lydia.
I don't know if this is a good or bad thing. I actually forgot that I was on camera. That's a good thing, I guess.
Oh, so you didn't even say hi.
I did. I said the date.
No, you didn't. You said the date.
Oh, I keep looking there.
Did you even turn it on?
Yes.
Okay. Julia. Hey, Julia.
Hi,
Julia.
Hello.
She watched.
Hi.
Hi, Sawyer.
We're all yelling things at the camera, so I got it.
We got a hi Sawyer, a hi Julia,
Ronnie.
a hi Johnny. Thank you very much.
I don't know.
Julia, Johnny, and Sawyer. The Heartland Middle School says hello and goodbye. Have a great weekend. That's the homework.
Bye, Julia.
Bye, Julia. Bye. Bye, Julia.